So I'm here with Sebastiano from Semidynamics.
Hi.
Semidynamics has made this rather bold statement that it doesn't really matter how many TOPS you have if the memory is going to get in the way of performance. So that sounds to me like you must have a solution for that.
Indeed.
What is the Semidynamics approach?
Yeah, so why so much focus on Gazillion misses? It's a technology that is built into the design of the CPU itself, deep down the data cache. And basically it allows us to trade latency, basically and hide the latency behind the multiple outstanding transactions that the CPU can cope with. And that allows us basically to do two things. One is we can stick to high capacity LPDDR. We are capable of tolerating the latencies of DDR without going to the packaging challenges that HBM presents, apart from scarcity. And the second thing is we keep tensor units fed with data, and they can crunch numbers, they can crunch multiplications without being stalled by the memory subsystem. That's why, if you want, Gazillion is a bit at the core of our solution for keeping the tensor unit challenged.
So, I mean, clearly it's an advantage to be able to use LPDDR.
Correct.
It's more available, it's more cost effective. Is it enough? I mean, do you get even more benefit if you were to use HBM or some other memories? Or you're just fine with LPDDR?
I think, yeah, the challenging part of HBM is packaging comes with a premium price, scarcity. There's basically one supplier in the whole world, so that basically pushes us towards LPDDR. But apart from that, the design is very flexible. So were we to switch to HBM in the future, if things change, yes, there's absolutely no problem, and Gazillion will still stand as an extra memory capacity offering.
Okay. Do I need to do anything in particular in order to use this architecture?
No.
Is it in some way proprietary?
It is proprietary, yes, but you don't need to do anything. It's conveniently hidden into the CPU itself. So it just you issue memory instructions and the CPU will take care.
Excellent. And tell me something about that CPU. So it's RISC-V based, and then you have this interesting approach where one architecture can behave as though it's many different kinds of cores. Have I understood that? You know, potentially it's like a CPU or a GPU or a TPU.
Yes. So compared to other AI inferencing offering, our programming model is simpler, if you want, because it's fully revolving around the ISA from RISC-V. Our CPU is compliant with the RVA23S profile, so it means capable of booting Linux. And on the side, we are compliant with the vector extension 1.0, and we also have a tensor unit offering, which is not yet ratified by RISC-V, but we are ahead of that, and we already have our own offering.
Excellent. It's a busy show here at ISC. I know you've got a lot to do. Thank you very much for talking.
You're welcome. See you soon.